Well, we got fair skies once again. A little bit of high cumulus showing up there, and we've got that stout southerly breeze bringing in tropical air from the Gulf. Welcome to Forecast Lab. It is spring, and we have another system approaching the area here. Now, in the southwestern U.S., this is that old Pacific front that has been moving south over the past few days. Looks like that's just past the Mogollon Rim, coming up on Phoenix there. And then further out east, we've got another Canadian system working southward. You can see those cool temperatures back behind that front, 64 there at Guyman, and 50s up near Garden City. So out ahead of that, we've got kind of a classic dry line there. It's along the Interstate 35 corridor, and we've got some very warm temperatures back in behind that dry line. Got some of our first 100-degree readings. In fact, let's switch over and take a look at that. And there it is. That's an Aviation Weather Center surface chart. And you can see we've got 102 degrees right there at Carrizo Springs, and 102 there at Zapata. That's well south of San Antonio, and 100 degrees all over the Rio Grande Valley. So it is getting to be almost summer. And on this graphic, you can see some of the moisture coming north. If I plot out the isodrosotherms, 60 would come up into East Texas, kind of like that, and up into Louisiana. It is kind of a meager flow of moisture. You can see there's just lots of 50s out to the west, and even just a very isolated tongue of 70s coming north. And that's a reason that we're not seeing a whole lot of convection with this surface front. And if we look at a forecast sounding, there's the profile. You can see that the moisture tapers off very rapidly off the surface. See 64 there at the surface, and it drops quickly off to 50s in the lowest couple thousand feet. So that is a problem for any developing storms. Definitely is a dry front. A lot of this activity here you see here is elevated. A few anvils showing up there north of Dallas, but they move off very quickly, and the very fast motion is another sign that the convection is elevated. If it was surface-based, we would be seeing much slower eastward movement. And that's because you're factoring in the slower low-level winds in the total wind vector. So what you saw in the opening clip was some of the stuff here, just elevated convection. There's a look at some of the convection as we try to put the show together. It's definitely elevated. In fact, when I go up to higher tilts, I'm going to go up to 0.9. Keep an eye on this area right there. If we go up to 0.9, you can see more echoes forming. So this is up at about 10 to 14,000 feet. So this kind of shows you a lot of the echoes here are mid-level features. Going back down to the surface, not much to see in the Dallas area, but if we switch over to base velocity, you can see the wind field. And what we focus on these clear air returns is not the colors themselves necessarily, but the zero line, the boundary between them. So we're looking at something like that right there. That zero line is perpendicular to the wind flow. So that means near the surface, your winds are blowing west to east. And as you go up to higher levels away from the radar, down here, keep in mind the radar is right there. So as you go away from the radar, you get to higher and higher levels since the beam is somewhat elevated. So when we get up to this level, up at about 5,000 feet, it's out of the southwest. Same thing on the other side. We can see kind of a west-southwest motion there. And to confirm that, we can go up to the higher tilts. Zero line will firm in just a little bit. And this shows that maybe we're just a little bit out of the west-northwest, like winds out of 280. Any possibility for convection? Well, if we go ahead to the high-resolution rapid refresh model, 5 p.m., it's going for a little bit of activity around the Kaufman area out towards north of Tyler. Now, that certainly could be elevated. And then we see more convection up towards Idabel, Tulsa. Yeah, and then around dusk, start to get a line as the convection gets into the deeper moisture. Then it looks like maybe around 9 to 10 p.m. a window of severe weather. Some of these, just their appearance on the high-resolution rapid refresh, suggests more surface-based storms in southwest Arkansas. And then it starts looking kind of disorganized and elevated by 1 a.m. So yeah, we'll check back on this as we wrap up production and see how things look. In the southeastern U.S., we've had a squall line come through much of western Florida. Now it's in the Tampa and West Palm Beach, Vero Beach area. And it's got a little bit of an outflow boundary looking like that. And on the forward edge, it's just north of Miami, where they've got a very hot 96 degrees. Yeah, and taking a look at the Miami page on Wikipedia, we can see the climate normals, and 96 is actually a record high, all-time record high for April. And the extreme high is 100, so that shows you the moderating influence of that tropical climate there. And so we run things back 24 hours, and you remember we had that squall line up there in Georgia and Florida. If we go through overnight, that first line comes through, and then we see another one form further west, approach Tampa 5, 6 a.m., and then the leading edge right down there. And that brings us to the current time. That's it right there, the squall line just north of Okeechobee, almost coming into Tampa, and the outflow boundary just out ahead of that. Pretty quiet in the northeastern U.S. We're still under the influence of that polar high coming in from Ontario and Quebec. I guess that cold air factory just has not stopped. Lots of 40s and 50s. And not much going on, just a disturbance off the very south part of the chart. That's probably that old low working its way up the northeast coast. And the visible satellite image shows much more to it. Yeah, there is some low pressure down in that area. However, off the northeast coast, in this area here, that's where the main occlusion is located. So it's well offshore, and then we got that northerly flow coming in back behind the system. And in the northwest U.S., mostly under the influence of Pacific air coming into Idaho, Oregon, and Nevada. There's also some Canadian air flowing south through the high plains, and I can make out a little bit of a Alberta clipper coming through North Dakota. It's a very slight difference in temperature between these mid and upper 60s and 50s and 40s up to the north. Same thing in southern Manitoba, low 60s, and you go north of there and you get into the 30s and 40s. Yeah, that's enough of a temperature difference to put a front there. However, that's going to be well north of the main storm track, which is down in the south, which is down in New Mexico and Texas. There's the visible satellite imagery, and yeah, certainly there's some instabilities with that surface system. And I'm going to draw out the fronts. There we go. Yeah, some storms along the cold front, and also some showers north of the warm front there. That would be west of Winnipeg. Yeah, it looks like a little bit of an upper air system right there, maybe a little kind of a small scale upper level low, because we can animate this and see the cloud rotation there. That's going to be mostly mid-level rotation. So I'm sure if we went up to 700 millibars and looked at that, we would actually find a circulation right there. In fact, why don't we go do that? Yeah, there it is on the NAM chart. This is going to be for 10 a.m. You can see that little area of rotation in southwestern Saskatchewan, and then in the afternoon it moves down into northeastern Montana. And if we go up to 300 millibars, we can see that that's definitely a mid-level feature there. And then for Europe, yeah, we're also on YouTube. Do you get weather for Saskatchewan and Germany? Yeah, I think we got a cold front coming through Germany there. A little bit of a wind shift, 60s along the cold front, dropping off very rapidly to 40s. So that's just another reinforcing shot of cold air coming out of Scandinavia. And that's continued to keep things kind of cold there in the UK. There's how it looks on the GFS, the isobars and thickness. So if we draw the fronts, they're going to run something like that right there. Low pressure there in eastern Poland, and then north of that, the cold air coming south. And looks actually like a little bit of a cold air trough back there in Denmark. You can see the main upper level low, well, at least a piece of that moving over Denmark. So probably a little bit showery there in Copenhagen this evening. I was also asked to take a look at the weather in New Zealand and Australia. Got to keep in mind it's the opposite of what it is in the Northern Hemisphere, so conditions there are pretty much like what we would see around October 25th in North America. So quite a few storm tracks out there to the south. New Zealand is located right there. Australia located right there. And usually what we see is these cold fronts moving west to east, and they kind of move sort of like that. So to understand it better, there's that old trick of taking it into a paint program and just doing a flip and then analyzing it in terms of what you are used to in the Northern Hemisphere. So if I were to analyze that in North America, that's probably what I would come up with. And then flipping that back, there you go, there's your surface analysis. Looks like a pretty potent system heading for New Zealand. Now, how would I forecast this? Again, I'm not too used to the weather there, but I would suspect there's probably a line of showers. It almost looks like thunderstorms. I don't know if they get them that far south. They probably do. But I would expect that to be moving, towards the South Island. Probably Christchurch and whatever else is down there. Auckland. No, wait a second. Auckland's up north. Wellington, Christchurch. Yeah, I'm not that familiar with the geography there. But anyway, this is the area that I'm looking at for conditions to go downhill. And you can see that the west coast gets the brunt of these systems, and most of the populated areas are on the east coast. So that kind of lessens the intensity by the time they get on the other side. So there you go, the analysis for anybody that's following weather in that part of the world. And then for Melbourne and Sydney, getting that cold southerly flow coming up from the southern seas. Well, checking back in on things after about an hour of production and editing. Still looks like a lot of elevated activity. And the visible satellite imagery shows that elevated stuff is separate from that other area of convection that the high-resolution rapid refresh model had forecasted. Remember, it was going for storms developing east of Dallas. That's going to be in that little area of cumulus right there. There's Dallas and there's Fort Worth. And we can zoom in and take a closer look at that. So there's that area of convection in the Dallas area. It's like most of it's focused on the Waxahachie area right there, and it extends down to Hillsboro and then west of Waco. Now, it does have an elevated look, so if I'm actually forecasting this and looking at things, that's what I would see. It's got an elevated look, and you can see the shadowing also indicating the great vertical extent. And with this kind of appearance, it's going to be high-based. Now, we do see a little area of moisture out to the west around, or to the east around Tyler, but that's also in the process of eroding as it moves west to east. So the question is, how much moisture is out ahead of this? So what I'm going to do is load up Digital Atmosphere here, and I've got it loading some MADIS, very high-resolution mesoscale data. This is kind of built into the data retrieval. And for any of you interested in Digital Atmosphere, I'm going to pop up this link. You can click on that if you want to download the program or learn more about it. So it takes a little bit of time because there's a huge number of rows in the data, but we're going to have it here very shortly. Now the key here is to turn down the data crowding. See down, I usually have it kind of cranked up. We've got to let all that data come through. And you can see it is a little bit of a mess. So what I'm going to do is I'm going to zoom in on this. Okay, so that little area of congested clouds is right in there. And if we look out to the west, you can see that the dew points are lower. So this is going to be the post-dry line air. And out ahead of it, that's the area we're interested in. We see that the dew points are in the low to mid 60s. So around Kaufman, 68, 66 there at Athens. Or I guess that would be around Maybank. Anyway, yeah, that's there is moisture there, but we can see by the lack of low cloud that that's going to be kind of a shallow layer of moisture. So there is some question whether these are going to become surface-based during the next couple of hours. And this is what I'm getting for my mesoscale analysis. Dry line all the way from Dallas down to Waco, all the way down to Austin. And you can definitely see the air mass difference. See down here, east of Temple, 62 to 64, and then on the other side, 50s. Well, we took a little break, and you can see that's pretty evident. That's the dry line there. Very slow advance eastward, going through the eastern suburbs of Dallas. And there's the storms. They kind of formed along the dry line and kind of detached, and now we find them a little bit out ahead of there near Corsicana. So we'll probably go out and take a look at them. So here's a look to the south. We pan to the west. And there's one of our tail-end storms here. In fact, this probably is a tail-end storm. And we can see it's pretty much an orphan anvil. Most of it consists of downdrafts. And we can see very little updraft on the upshear side way back there. So, yeah, this is just a big old anvil spreading over us. And you can see little elements of mammatus right there. And there's a little more of that mammatus stuff. Yeah, and that's not going to be a good sign. The sun coming through the anvil. Road a little bit towards the northeast, about 10 or 15 miles. We're in Frankston, Texas. Not a whole lot to see. Things are pretty disorganized. Looks like there's not really a common boundary for things to form along, and cells are just kind of going up everywhere. And they don't have much moisture either. They're kind of elevated, these bases. They look to be up at about 5,000 or 6,000 feet. Yeah, there we are, some cells just to the east and northeast. Well, that's the story of what happened today. We gave it a shot, but the storms were so pathetic they couldn't even keep their anvils. So just a bunch of congested towering cumulus, and well, that's all that we're seeing, and there's a few cells up to the north that definitely look better. You can see that at the top near the Bonham area, but that's way out of range here. Some nice overshoots on those cells way up to the top. Let me scroll that up. Yeah, see that up here? Check that out on the Fort Worth radar. And here's the pathetic play-by-play starting at 6:30. We run that forward and just a bunch of disorganized elevated cells around the Tyler Longview area. And that's all we got. And then up to the north, that's where the good stuff is. Well, probably not so good if you live up there, but anyway, those are definitely some good hailers up there at the very least. They've got kind of a supercellular structure. I don't know about rotation. I'll have to take a look at that. This is really a bad area for sampling storms because of the distance from the radars. We can see that the velocity is dominated by outbound motion. That's a combination of cell motion, but mostly due to the strong upper-level winds. See, this is up at about 14,000 feet. See that readout down at the bottom? Like, let's see, right there? Yeah, see, that's 14,000. So we're up in the mid-levels, and there's some pretty good mid-level wind. So if we want any hope of trying to uncover storm motion, we need a set of motion vector. So let's do that. I'll just stick in 240 at 40 and see what happens. Okay, I think we do have a couple of good circulations. One is there, and one is up there. This is in the Paris area. So let's go back and correlate that with the storm. There's inbounds, there's outbounds. We've got kind of a broad mid-level rotation right there. It's 100 miles from the radar. So that's going to be a problem. And some broad scale rotation right there. So I'll set a dot right there in the middle. And you can see that that's kind of on the right side of that storm. We can try doing a cross section there, but it's really blocky because of the significant distance. We really need some radars in that area. Paris has been hit by tornadoes in '82. Could certainly happen again. And this for sure, the Tyler area also needs a radar. Anyway, so that's how things look. I'm going to go ahead and get this edited and uploaded since we're behind schedule. Keep in mind that tomorrow is the weekend. Saturday and Sunday and Monday are reserved for our supporter-only streams. So if you want to get in on that, you'll need to sign up on Patreon, and there's the address, patreon.com/metlab. And once you get set up there, you'll be able to get the private streams. Otherwise, you'll have to wait till Tuesday when we restart our normal video rotation. All right, so let me go ahead and get this uploaded. Have a good evening, and we will see you soon. Bye-bye.